Okay, this is lecture 4. This is another example. I'm going to tell you right out, this is a really advanced example. I'm still trying to just give you a feel for what's going on. So some of the instructions that we're going to use here, you haven't seen them before. You're not going to understand exactly what they're doing. But once again, don't worry about it. Just kind of get a feel for what's going on in this thing. So this is a program. Let's see what it wants you to do is read data from the switches. It complements that data and outputs the data to some LEDs. Okay, so this is potentially a meaningful problem in that we have a microcontroller that is interfacing with hardware in the outside world. So namely, data associated with switches, and then it's reading that data from the outside world. It's crunching it around, which means it's going to complement it. That's all we're going to do. And then we're going to output that data to back to the outside world, which is what we're going to use that to drive some LEDs. Okay, so a real example, reading external switch data, crunching the data by complementing it, writing that data out again to the outside world to some LEDs. And we're going to do that over and over again. So once again, I guess I didn't say that in the program, this is a full program. These programs never end. They just keep going and going. They don't have halt or stop instructions or anything like that. They keep going. So the first thing is in this program here is that the instructions here are, I need to use these instructions such that I can get data in and out of this thing. And what you're going to find is the in and out instructions are exactly these load instructions, right? Load and store. We don't have to worry about it right now, but as you can see, they all have these 2 operands here. Actually, it was 3 operands, but we don't have to worry about that. So what I want to do is to load data. I'm going to read data from the outside world. I'm going to load it. To write it, I'm going to store it. Okay, once again, you don't need to know that. We'll talk more about it later. But the idea here is that with these instructions, this right here is essentially the address value, and this is a register value. I need to get that address into a register so I can use it in this instruction here. And so that's going to be the first thing I do in this instruction, which is going to be a load immediate x10, and I'm just going to steal these addresses 00x C0000004. Okay, I'm going to do that with the other register too. Load immediate x11. I'm going to take the other address C000000A, and once again, these are nothing special with these numbers. The person who designed the hardware has to give you these numbers, and so for this problem, someone gave you the numbers. Okay, so the first thing I want to do is read this data in, and what I'm going to do is take it in from the outside world and put it in a register. So I'm just going to use a load word instruction. I'm going to put it in some random register. You don't need to know about this part here, but this is switch data and LED data. And here's the address of the switch data, which is x10. And so what this instruction is going to do is take that switch data, or take the data that's on those switches, read it, and put it into that register. Okay, so I have the data in the register. Next thing I want to do is complement that data. And so I'm going to use my complement instruction, which I don't have a complement instruction. So which is the common occurrence in assembly language. You don't have the instruction you're looking for, but there's always ways to get around it. And so what I'm going to do in this instruction, instead of a complement instruction, I'm going to use an exclusive OR. So I'm going to exclusive OR it with a bunch of 1s. Anytime I exclusive OR a single bit with a 1, it's essentially a inversion. So I'm going to take advantage of that characteristic of an exclusive OR. And so let's do it. XOR. I'm going to wimp out and use this immediate instruction, and I can store it wherever I want. But x20 and minus 1. Okay, so here's the immediate value. The assembler is going to change that minus 1 into a whole bunch of 1s. Anytime I exclusive OR a bit with a 1, it toggles the other bit, which is what is happening on this thing. So this exclusive OR gives me a toggle for a bitwise toggle. Stores the result in x21. Once I have those bits stored in x21, I need to write them to the outside world, to the LEDs, so I'm going to use my store word, which is how I do output instructions. So you'll find there's no output instruction, which is something you don't need to worry about. We'll talk about that later. And I'm going to write the data in x21 to somewhere, but I know it's going to use this address up here, and I already put it in x11. The store word instruction works with registers. It doesn't work with immediate values. I have to use a register. Okay, so that's the meat of my program. But what I want to do here is do this over and over again, and so I'm going to toss in a label here. So there's my jump instruction. I'm jumping to the instruction associated with the main label, and I'm going to do it again. So the way this instruction is going to fire up is it does this, then it jumps back and does this, jumps back and does this. And that's my entire amazing program from start to finish. I know there's a lot of stuff in here that you're new to, but don't worry about it. We'll cover that in more detail later. The next set of lectures will have more useful information in it.